Going to draw a circle. This is the x-axis. This is the y-axis. If I draw a triangle, starting at the origin or my vertex, this is the radius, this is the y value, and this is the x value. This is theta. Theta is always closest to the origin. It's never going to be here or here. It's going to be by the origin. So let's look at some basic trig functions. If you remember from geometry, you learned SOH CAH TOA. S stands for sine. The O in SOH CAH TOA, the O stands for opposite. So in this case, sine of theta, let me squeeze in a theta. Sine of theta is opposite over the hypotenuse, which is your radius. C stands for cosine. So cosine of theta is the adjacent side, which is the side that's touching the theta. So x over the hypotenuse, which is r. T stands for the tangent. So tangent of theta is the opposite over the opposite over adjacent. So y over x. Now, cosecant, CSC of theta, cosecant, we use this letter, and this letter for cosecant. Cosecant is the reciprocal of sine. So the reciprocal means you flip the fraction. So instead of y over r, we're going to do r over y. For cosine, you're going to get secant. Secant is the reciprocal of cosine. So we're going to write secant as SEC. Secant of theta is r over x, the hypotenuse over the adjacent. For tangent, the reciprocal is cotangent. And we write it as COT. So cotangent of theta is x over y. Okay, so let me give an example really quick. Let's say I have the point 3, 4. That means I'm going to go over 3 on the x and up 4. And this is the triangle that I formed. This is 3, this is 4. This is the point 3, 4. Okay, my theta is always on the inside that's touching the origin. So that is my theta. If I want to figure out the other side of my triangle, I'm going to do Pythagorean theorem. So 3 squared plus 4 squared equals my radius squared. This is 9 plus 16, which is 25. And the square root of 25 is 5. So that means my radius is 5. So I can go ahead and draw my circle properly. I know that I'm dealing with a circle with radius 5. I'm going to go out 5 on each side. Okay, so this is my circle with radius 5. Okay, now that I have my triangle completed, I can now look at my trig definitions. So sine of theta is, remember, SOH CAH TOA. So for sine, I need opposite over hypotenuse. So that's 4/5. For cosine of theta, I want adjacent over hypotenuse. That is 3/5. And for tangent of theta, I want 4/3. Opposite over adjacent. Now, I'm going to do the reciprocals of these. The reciprocal for the sine is cosecant. Cosecant of theta, just do the reciprocal, is 5/4. Secant of theta is 5/3. And cotangent of theta is 3/4. Let's try another example. All right. Let's say my point is square root of 2 and square root of 9. That is my point. So if I were to draw this, here's my x-axis and y-axis. I know that I'm going to go square root of 2 this way and square root of 9 up. And I need to find what my radius is. So the square root of 2 squared plus square root of 9 squared will give me the radius squared. Those cancel, leaving me with 2. The square root cancels out with the squared, leaving me with 9. Sorry, let me make this a little easier. Let's change this to a 7. I'm going to change the problem and make it a 7. Okay, so that cancels. I'm left with 7. So 2 plus 7 is 9. Now I need to square root this. So the square root of 9 is 3. So that means my radius is 3. That's a better problem. Okay, so now let's find the different identities. Remember, theta is your inner angle with the vertex at the origin. Okay, so sine of theta, we're going to go opposite of theta. That's square root of 7 over the hypotenuse. Remember, it's SOH CAH TOA. So we did opposite over hypotenuse. And you're always doing it from the perspective of theta. So opposite of theta is the square root of 7 side. So I put that in the numerator. Next is cosine of theta, which is square root of 2 over 3. And tangent of theta is square root of 7 over the square root of 2. Now, you cannot leave this as your answer. You do not leave square roots in the denominator. So I'm going to multiply by square root of 2 in both the numerator and the denominator. This becomes square root of 14 over square root of 2 times the square root of 2 is just 2. So this is my answer for tangent. Something you need to remember here is that square root of a times square root of a is just a. Just like square root of 9 times square root of 9 is 9. Remember, square root of 9 is 3, square root of 9 is 3, and that's equal to 9. So you need to remember this little rule. Okay, now let's do the reciprocal functions. The reciprocal of sine is cosecant. Or cosecant is the reciprocal of the sine. So I'm going to do 3 over square root of 7. Remember, you cannot leave a square root in the denominator. So please get rid of it. Your answer is 3 square roots of 7 over 7. I'm going to let you guys find secant and cotangent theta. Okay. Let's talk about the unit circle some more. So far, I've only given you triangles that were formed in the first quadrant. So now let's talk about the second quadrant, the third quadrant, and the fourth quadrant. Remember, anytime you form a triangle, you need to have a side on the x-axis. So this triangle, it has a side on the x-axis. This triangle has a side on the x-axis. Here is a triangle that has a side on the x-axis, and this is what a triangle would look like in the fourth quadrant. Okay? Those are the 4 different types of triangles you can create. You will not, please don't make this mistake, you will not have a triangle with a side on the y-axis. You will not have anything like that, okay? You're always going to have a side on the x-axis. Okay, so let's look at the third quadrant. Or sorry, let's look at the second quadrant. Here's my theta, and here's my theta for all of these triangles. It's always that inner quarter closest to the origin. Notice, guys, I went negative x on this side because this is the x-axis. The x-axis is positive on this side, but negative on this side. we still went up. So these are positive y values. Because this is your y-axis, and it's positive above the origin. So let's look at sine and cosine in the second quadrant. So we're looking over here. Sine of theta is opposite over your hypotenuse, your radius. So that's y over r. Cosine is adjacent, and look, that's a negative x because you went to the left. So that's negative x over your radius. Your radius will always be positive. So all of these radiuses, those are positive. The only thing that will be negative is your x, possibly, or your y can possibly be negative. But your radius is always positive. There's no such thing as a negative radius, right? Because you're doing distance across a circle, or from the center of the circle to the edge of the circle is your radius. Okay. That means your tangent is y over a negative x. So notice, the value of sine is positive. The value of cosine is negative, because you have a negative divided by a positive here. And here, the value of tangent is negative, because of this negative here. Okay? So what I want you guys to think of is whenever you're thinking of sine, I want you to think about the y-axis. When you think about sine, think about the y-axis. When you think about cosine, I want you to think about the x-axis, okay? So let me draw another circle for you. This is your x-axis. This is the y-axis. Notice your y-axis is positive on this side only. That means your y value is positive in the first quadrant, and your y value is positive in the second quadrant. Okay, so what I'm trying to tell you is that sine is positive in the first and second quadrant. Okay, now let's talk about the x-axis. Okay, your x-axis is only positive on this side. This is the positive side of the x-axis. So that means the first quadrant and the fourth quadrant is when your cosine is positive. So cosine is positive in the first quadrant and in the fourth quadrant. So if you guys still don't get what I'm saying, let me draw you a picture. Here is a triangle. This is your radius. I went down and I went to the right to form this triangle. This is a positive x value. So that means your cosine is, this is your theta, adjacent. So x over your radius. Your radius is always positive, so that's positive. However, let's look at sine. Notice this triangle is down here. It's below. These y values are negative. You went down. So your sine of theta is negative y over the radius. That's negative. And since you have a positive for cosine and a negative for sine, that means your tangent is negative. Okay? So I want you to think about, where is sine positive? Where is cosine positive? Where is tangent positive? I'm going to pause here for you to think about it. Okay, so sine is positive in the first and second quadrant. Cosine is positive in the first and fourth quadrant. And tangent is positive in the first quadrant and the third quadrant. Good. Okay, I'm going to do another example. So let's say that I have the point negative 8, 6. That means I'm going to go with negative 8 to the left. 1, 2, 3, 4, 5, 6, 7, 8, and then up 6. Okay, so this is negative 8 and 6. I need to figure out what my radius is. So if you do Pythagorean theorem, 6 squared plus negative 8 squared is 100, and the square root of 100 is 10. So my radius is 10. All right, so now I can go ahead and find my different definitions. So I know that sine of theta, this is my theta in that inner corner, closest to the origin. Sine of theta is, remember, so opposite, 6, over the hypotenuse, 10. If you leave your answer like this, it will be marked wrong. You always need to simplify your fractions. So we can divide both the numerator and the denominator by 2. So your answer is 3/5. That means the reciprocal, cosecant theta, will be 5/3. I'm going to pause here and let you guys finish this one. Okay. So cosine of theta, your adjacent side is negative 8 and your hypotenuse is 10. Simplified, this should be negative 4/5. Secant of theta, you take the reciprocal, so it'll be negative 5/4. So these are those two. And for tangent of theta, you have opposite, which is 6, over the adjacent, negative 8. This simplifies to negative, we're going to divide this by 2 and this by 2. So we'll get negative 3/4. And cotangent of theta is negative 4/3. Next problem. If sine of theta equals 5/8 and theta is in quadrant 2. Okay, let me pause there and draw this. Remember, sine is opposite over the hypotenuse. So let me get a pen here. So sine is opposite over the hypotenuse. So I know that this angle is in quadrant 2. So I'm going to go right here. This is my angle. I know my opposite is 5 and my hypotenuse is 8. So it's going to look something like this. Let's not use exact dimensions here. Just forget that this is on a grid because I don't know what this value is. They just told me that this theta, the opposite is 5 and the hypotenuse is 8. Okay, so this is not an exact sketch. This is very rough. I do not know what this is equal to. I don't know the adjacent side. Okay, but that's what my picture looks like. So let's figure out that missing angle. We don't know, I'm sorry, let's figure out that missing side. So I'm going to do Pythagorean theorem. I know 5 squared plus this missing side squared is equal to the hypotenuse squared. So this is 25 plus x squared equals 64. Let's solve for x squared by subtracting 25. So I get x squared equals negative, I'm sorry, not negative, 39. Now I'm going to take the square root of both sides. So that is my missing side. So this missing side, the value is negative square root of 39. And the reason why I'm doing negative is because we moved this to the left. We're in the second quadrant. In the second quadrant, the x value is negative, right? That's why I have a negative square root of 39. Now that I have all of my sides, I can go ahead and find my different definitions. So sine of theta is, well, they gave that to me, sorry. Cosine is adjacent, so negative square root of 39 over the radius, which is 8, the hypotenuse. And I want to find secant. So all I have to do is do the inverse. So this is 8 over negative 8 over square root of 39. And of course, do not keep the square root in the denominator. So this is secant of theta equals negative 8 square root of 39 over 39. That's one of them. Now let's find cotangent. So normally tangent, SOH CAH TOA, tangent is opposite over adjacent. So if I'm going to find cotangent, I need adjacent over opposite. So cotangent of theta is square root of 39 over 5. Oh, and don't forget that negative because it's on the left side. And that's it.